solve for t. So we have t plus 1 times t minus 5 equals 16. Now we cannot use the rule where we set this equal to 16. The reason is that only works if a times b equals 0. So basically if your two binomials multiply to equal 0. Now what we can do though is we can set this equal to 0. So what we'll want to do is subtract 16 from each side. So we'll get t plus 1 times t minus 5, minus 16 equals 0. Now again, we can see this is still not in the form a times b equals 0 because we have this minus 16. So we need to simplify this out, combine all the like terms, and then go from there. So we'll multiply, we get t squared minus 5t plus 1t, and then minus 5. Minus 16 still equals 0. So we'll do t squared minus 5, let's erase that. Let's combine that term. So we have t squared minus 5t plus t, we get minus 4t, and then we have minus 5 minus 16. So together that will give us minus 21 equals 0. So now at this point we want to factor it again. So we want to look for factors of negative 21 that add up to negative 4. Well, the first ones that come to mind are negative 7 and positive 3. Does that work? Well, negative 7 times 3 does give us negative 21. And negative 7 plus 3 does equal negative 4. So that will work. So we can write it as t minus 7, t plus 3 equals 0. Now at this point we can use this a times b equals 0. So if a times b equals 0, then either a equals 0 or b equals 0. So we'll set each of these equal to 0. So t minus 7 equals 0, t plus 3 equals 0. Add the 7 on both sides here, so we get t equals 7. Subtract the 3 on both sides, so we get t equals also a negative 3. So those will be our two answers. Now I did a quick check just to make sure we don't have any denominator. So we don't need to worry about extraneous solutions, and those will be our answers.